Hello, my name is Izzy. I work at Bunder Difflin, and this is our litmus paper company. I've been the regional manager here for 12 years now. Here, let me show you around our building. Safety glasses first, remember. Thanks, guys. All right. We try to keep it pretty loose here, pretty fun. The only law that we abide by is the law of conservation of mass, which states that no matter can be created or destroyed. See, we used to be a paper company, but that wasn't really a valid option, so we changed it to a litmus paper company. Almost overnight, we brought in an extra crew. It kind of acted like a catalyst and sped things up a little bit. I like to think we're more than coworkers. We're like a little family here.
We're not a family. I end up taking most of my work home. Nobody thinks we're a family. It's common knowledge around here that I tend to procrastinate a lot at work, so I end up taking most of it home. Right now, I'm working on a combustion reaction. I like combustion reactions because they always have the same products, H2O plus CO2. All you have to do is balance the equation to abide by the law of conservation of mass. Here's my equation for the combustion of methane. All we have to do is simply add a 2 here and a 2 here. This is an example of a complete combustion reaction. We can tell because it produces carbon dioxide, or CO2. In an incomplete combustion reaction, it will produce carbon or carbon monoxide, or both instead of this.
So, Matt and Emma don't seem to be doing so well, do they?
Yeah, you know, they're kind of...
I don't understand.
Okay. You know, they're not really a thing anymore.
I don't get it.
Okay, so you know how they were together?
Yeah.
Okay, well now they're not.
What?
Okay, think of it like a decomposition reaction. They were together, yes, and now they reacted, yeah, maybe with some heat, and now they're not. Okay, all right, you know what? Here, take a look at this. See how the one compound decomposes into 2 or more substances?
Yes.
Okay, so you understand what I'm saying now.
No.
Here, let's look at this example. We know the formula for table salt is NaCl. Well, this can decompose into Na and Cl. We also know that Cl is part of Hoberfinkel, so it exists as a molecule. Now that we have this, we have to obey by the conservation of mass. In this example, we simply have to add a 2 in front of the NaCl and a 2 in front of the Na. Sometimes decomposition can be caused by heat. This is called a thermal decomposition. So, do you understand now?
No.
Oh, hey Val, what you working on?
Oh, just a synthesis reaction.
Oh, synthesis reaction, yeah. Yeah, I know what that is, but just to make sure that you know, could you explain it for me?
Yeah, okay. So a synthesis reaction, sometimes called a composition or a combination reaction, is when 2 or more things combine to make one thing. It can be ionic or molecular. It's an easy one to recognize. 2 reactants become one product. Sometimes it can be associated with the combustion of fuels. Let's take a look here at my example. Here we have carbon and oxygen. Because this is a synthesis reaction, we know the product will be this element and molecule combined. Carbon has a charge of 4+, and together the oxygens have a charge of 4-. So they simply react to create carbon dioxide. It's also very important to obey the law of conservation of mass. Luckily, our equation is already balanced. Hi, I'm Izzy. Can you help me with this single surface reaction real quick?
Oh yeah, sure. It's really easy. Let me show you. Here, it looks like this. When one element replaces a similar element in a compound.
Oh, that makes sense. So a metal can only replace another metal, and a non-metal can only replace a non-metal.
Exactly.
So in my example, Copper will react with silver nitrate to make silver and copper nitrate.
Yes. Well, maybe. First, we have to check the activity series to see if the reaction will take place.
What's an activity series?
It's like the order of power for elements, like how in this office, the manager has the most power, then the regional manager, then the assistant to the regional manager, then the assistant to the assistant of the regional manager, and so on.
I'm not sure I follow.
Here, look at this. In your example, copper is higher on the scale than silver. If we had gold instead of copper, then the reaction would not take place because gold is lower and less reactive than silver. If this was the case, then we would write NR for no reaction.
Okay, I think I get it now. Now that we know our reaction will take place, I can write the products. The copper is now with the nitrate.
Now all we have to do is obey by the law of conservation of mass. All we have to do in this example is put a 2 in front of the silver nitrate and the silver. So now you know how to do a single displacement reaction.
Emma, I've brought you here because I've noticed you've been having some trouble with your double displacement reactions recently.
I protest.
Save it to the end.
Fine.
So we already know a double displacement reaction is when two reactants combine to form two new compounds, like this. In simple terms, they change partners.
Easy, give me my science back.
But here's the tricky part. We use a solubility chart to predict the state of an ionic compound and if the reaction will happen. Here's how we use the chart. We simply look under the name of the last component of our ionic compound and use what's paired to find the state. Here's an example. KNO3 would be AQ because K is in that section. It's also important to add that water is always a liquid.
But how do we know the reaction will happen?
One of the products created must be either a liquid, a gas, or a solid. The rest must be precipitates. It's called a precipitation reaction when a solid is formed. A reaction producing a gas is when a gas is formed. And a neutralization reaction is when a liquid is formed. Let's look at an example. NaI plus CaCl2, by looking at our solubility chart, we can see both of our products are precipitates, AQ. In a double displacement reaction, we know that they are going to switch partners, so our products are NaCl and CaI2.
We get it. The reaction happens.
Well, first we have to check. Let's look at our solubility table. Uh-oh, both of our products are also AQ, meaning this reaction won't happen. In this case, we would simply write NR for no reaction. If this wasn't the case, we would need to use the law of conservation of mass and balance our equation.
You're all fired.
Here,
wanna try again?
I can just cut all this.
Hey, what's up?
Carbon has a charge of 4+, and together the oxygens have a charge of 2-. That's not right. Hi, I'm Izzy. Can you tell me what this double displacement reaction real quick?
Oh yeah, sure. Yeah, it's obviously a double displacement.
Yes,
Here,
I have
yeah,
that.
let's look
I have
at
that
this.
written already.
Yeah.
It's true. You can see
It's
it.
not, it's a single displacement what we're working on right now.
Oh right, it's single displacement. Oh,
do this again.
I think I got the wrong facts. I'm sorry. I'll come back.
Easy, give me my science back.
Get it back.
Get it?
Get it back.
Trade with me. Trade.
Trade what?
Trade, no.
So now you know how to do a signal. Nope, we're doing that again.
See, one thing about our lab is we don't have any glass containers that aren't broken. And it kind of sucks. That's what we do here at Dinner Muffin.